Now, a couple questions specifically about principal and doubling. Okay, so the question is, how long does it take to double the principal at 3% annual interest compounded continuously? Now, we've already seen and worked on problems where interest at a certain annual rate compounded a certain number of times annually doubles. So let's see how this one works out. Okay, so what we have is, we have P of t equals P naught e to the 0.03 t. And you know, I said something wrong here. I said this was interest compounded continuously at 6%, and that would be at 106%. So I misstated this. Still, okay, here we have the function. We want to see how long it takes to double. I'm going to write it like this. I'm going to use T sub D for doubling time. And this is our principal after the doubling time. And this should equal double the initial principal. The initial principal is P0, P naught, because when T equals 0, if T equals 0, principal equals P0. Okay, so we have this equation, and we want to solve this equation. Well, the equation is pretty easy to solve. I think I'm leaving myself enough room. If we divide both sides by P naught, we get E to the 0.03 t sub d. Again, t sub d stands for the doubling time. And that's going to equal 2. To solve this, we simply write this as log the base e of 2 equals 0.03 t sub d. Log to the base 2 is the natural log, so we're going to get 0.03 t sub d equals the natural log of 2, which you can calculate with your calculator. So t sub d is a natural log of 2 divided by 0.03. And take that to the calculator. Okay, it's going to be about 18. So if you get something besides 18, wait a minute, that's going to be about 24. Okay, it's going to be about 24. If you get something too much different than 24, either I was wrong about that, or you didn't use the calculator right. And you can always check it by putting that number back into the expression, e to the 0.03 t sub d, and evaluating it, you should get 2. Okay. So, another question, if principal doubles in 12 years, what's your continuously compounded interest rate? Well, in general, P of t equals P sub 0 times e to the RT. In this case, you don't know R, but you do know the doubling time, 12 years. So we know that P naught e to the R times doubling time is equal to 2P naught. If you put the doubling time in here, you're going to get double your initial principal. Remember, your initial principal at t equals 0, e to the 0 is 1. Your initial principal is P naught. That's why we use 2P naught for the doubled principal. Okay, so we have this. What else do we have? Well, the doubling time is 12 years. So we have P naught e to the 12R equals 2 P naught. Divide both sides by P naught, we get E to the 12R equals 2. So that log to the base E of 2 equals 12R. And of course, log to the base E of 2 is a natural log of 2. So the natural log of 2 equals 12R. So that R is 12 over the natural log of 2. So what we're going to find is that's about, should be about 6, but when I estimate it, oh yeah, okay, never mind. And doing all kinds of things carelessly, so that was totally wrong. Again, that's why we check things. Okay, we get R, it's a natural log of 2 over 12, and that's going to be a little less than 6. Let's say 6, it's probably going to actually be about 5.9, okay, 5.8 something, 5.9, okay. So there we have the solution here. So I'm going to give you a couple of problems of this nature.